All right, welcome to 14.5 Descriptive Statistics. To save time on the video, I'm going to have you pause and read the paragraph that's below. So if we look at the first example, the stem and leaf plot is given. We want to find the median and the mode. If you remember from previous years, median is the middle number and the mode is the most occurring number. So we're looking at swimming times in the 50-yard freestyle event. Now when you look at a stem and leaf plot, there should be a key at the bottom. The stem is part of the number and the leaves is basically a way to save time. So in this instance, you can see the key below, so it's 39 bar 5 is actually 39.5. So it's a very nice organized way to collect our data. So if we think about the median would have to be the middle number. Well, if we count up the number of numbers here, total number of numbers is 16. So that means if we count up 8 numbers, we'll find the median. So median ends up being 42.7. If we want to find the mode, we want to see which one occurs the most. Well, you can see that there's 3 7s listed in the leaves. That's going to be the one that occurs the most, so that happens to be 42.7 as well. Again, I'm going to move on. I would pause the video and read this paragraph so that the video is not so long. Okay, so now we're on page 2. Excuse me. To find this, we're going to use the TI Inspire calculator, so you're going to need that out. Make sure it's charged. Use that the entire chapter. We're going to practice using data sets. We've already done this once before, but it'll be a good review. And what we're going to use is that standard deviation on the previous page. We're going to let our calculators use it. Standard deviation can compare 2 data sets that might have the same average. So if we look at the sample 1, 50, 58, 78, etc., it's going to have an average or mean of 72. If we look at sample 2, all those numbers in the 70s, they also have an average of 72. Well, we're going to show by the standard deviation that the sample 2 on the right, 72, is a much better indicator for the data set than 72 used in sample 1. So calculator keystrokes, again, I'm going to pause the video. I would read through these and then I'm going to take you back through how to do it on the screen. Okay, so we're going to open up a calculator, and then instead of having a calculator page, we're going to open up our calculator and we're going to add data, and we're going to add lists and spreadsheets number 4. And at the top, we're going to label this sample 1, make sure you have no spaces in between, and sample 2. And we're going to enter the data for sample 1 that was given in our notes. And I'm going to go ahead and pause the video to save time and enter in the rest. So at this point, you'll see I've entered all the data for both samples. Now, if you look at the notes, the next thing we're going to do is we're going to insert a new page. So we're going to go to Control Doc, which means add a page, and we're going to insert 2 new pages. We're going to add a calculator, Control, add a page, and add a calculator. Now, if we go back to 1.2, this is actually going to be our sample 1 data. So what we're going to do is we're going to go to Menu, Statistics, Stat Calculations, and 1 variable statistics. The number of lists, we're going to choose 1. For our X list, we're going to find sample 1. Then we're going to hit OK. So this data shows us what we need. So we're going to go ahead and fill in on our notes the X bar, which is the mean, the standard deviation, which is sigma, the minimum, which is 50, Q1, which is the first quartile, the median, which is also known as Q2, 78, Q3 is 87, we're going to fill in the maximum, which is 93. And then we're going to talk about the interquartile range. So these are all your different statistics that you would need. Okay, so pause the video and write down those answers. And you can see for sample 1 that I've recorded the data. Now we're going to take you through sample 2. So to get from page 1.2 to page 1.3, all you have to do is click on at the top with your cursor on 1.3. And then from here, we're going to go back to Menu, Statistics, Stat Calculations, One Variable Statistics. Now we want sample 2. And again, pause the video and record all these on your notes. So we all know what the median, the mean, and the mode is from previous years. But when we have data that's large and it's hard to tell, which one's a better representation. Think SAT and ACT scores. When you score one score versus another, how well did you score relative to the rest of the group? Sometimes this could be used to give a better accurate picture. So when we write down these things, we want to know that the first line is the mean. They both equal 72. The next line is the standard deviation. You'll notice that on the sample 1, the standard deviation is 15.73, whereas in sample 2 it's 0.63. The fact that it's less than 1 is a very good indicator that the mean and the data is really tightly packed. So 72 is a great number that we could use to show the kind of the average or the data set points. Sometimes it's more advantageous to show the median. For instance, if we look at the sample 1 data, the median was 78. We might want to use that as our data point to indicate our data set versus 72. Another one that we can use is the mode. Sometimes it's more advantageous to use the mode. For instance, the test scores. If everybody took a test and pretty much the whole class got A's, except for 1 or 2 people maybe got F's, the people that got F's could really pull the class average down. So maybe we want to use the modes and say, look, most people got an A kind of thing. Q1 is your first quartile. You'll see the minimum. That's your minimum in your data set. Q3 is your upper quartile, and Q2 is known as your median. So basically think of them as thirds of the data. You're going to cut the data in half with your median, and you're going to do the median of that first half of data, that's Q1, and then you're going to do the median of the second half of data, that's Q3. And then you're also going to have your maximums. Now your interquartile range is going to be very important to be able to calculate. It's going to be basically, we call it IQR, but it's Q3 minus Q1. That's something that doesn't come up on your calculator, but you can take the number that you get for Q3 and subtract Q1. And that also can tell you how much spread in the data is. You'll notice there's 33 points between Q3 and Q1 in sample 1, whereas there's only 1 space between Q1 and Q3 in sample 2. So go ahead and pause the video and read carefully the next paragraph. So again, just to remind you, I'm entering in my data points for male and female. I basically made a new document, and then I put my statistics on 1.2 for males and my statistics on 1.3 for females. So go ahead and pause the video again and enter your data. So I've written down the results for all of the calculations that we entered into our spreadsheets, and you can see them listed on the notes here. And now we're making a table, and what I'm going to do for the table, I'm just going to show you what's called a box and whisker plot, or the book calls it a 5-number summary, but most of us call it box plots or box and whisker plots. So I've picked out a range based off the numbers that I see. I went up by 5s, and with 25 being the minimum number plotted, 75 being the max, because I know that my max on one of them is 74, and my min on the other is 29. So I think 25 to 75 is appropriate with the scale. And I'm going to show you how to make a box and whisker plot. So we'll use the males. We'll do those in orange. So we're going to do the males in orange. So what we're going to do, the first thing we're going to do is we're going to plot the median. So we're going to kind of work our way inside out. So Q2 is the median. So we're going to go to 41 and put a line. And then we're going to go to 48 and put a line. And then we're going to go to 30.5 and put a line. And we're going to make basically a rectangular box out of that. And we're going to label this Q1, Q2, and Q3. we're going to say what they are. So 30.5, Q2 was 41, and Q3 was 48. And you can tell that based on this data that the median of Q2 of 41 is slightly pushing toward the 48. So that can kind of show you that the different values and what's occurring more versus 30.5 is way to the left. There's more spread there. You can kind of see if you list out the numbers, it means there's more variability there on the lower half of the numbers. Now, if you connect the whiskers are the next part, the whiskers to the min and the max. So I'm going to go to 55, and I'm just going to put a little, and I'm going to connect the whisker. That's called the whisker. And then I'm going to go to 29 and put a little dot. I'll connect that whisker. That's 29, and this one's 55. So while you can see the median's 48, you can see that 55 is quite a bit further away from it in terms of extremes. And then 29 is the lowest point. So this is a quick way to identify what are your medians and what are your max and mins. Now we're going to go ahead and do the female thing as well. I'm going to pause the video, see if you can do it. So now you can see I did the female group in green, you can see that the female group is more tightly packed. So when you look at the data, if you just kind of glance at it, you can see that the female scores there's less variability. You can tell the fact that the box itself is closer and tighter together. You can see that the whiskers don't extend as far in each direction. They don't have as high and as a low value. So we know that the data set for the females is going to be much more accurate. Now, the other thing I want to show you is what happens when we have outliers. This is kind of what I was talking about with test scores. Sometimes I consider outliers and I just throw them out because they can really mess with the averages of the data. So in order to find an outlier, I must take 1.5 times the IQR. Okay, so if we're doing the males, and we have 1.5 times 17.5, and that's going to equal 26.25. Now what that means is if I take 26.25 and add it, I don't want you to put this on your diagram. I'm going to use black for a different color to show you. If I take 26.25 and add it onto the so if you take that IQR 26.25 and you add it to Q3, well, 26 added to 48 is going to be 74ish. Well, 55 is under that, so there are no outliers. Same kind of thing on the other side. If we take Q1, which is 30.5, and we subtract 26, going to the left, if we subtract 26.25, well, 30.5 minus 26.25 is just under 4. So the lowest value that would be an outlier would be anything under 4. 29, since it's our min, we know we don't have any outliers. However, I want to show you what happens when we do the IQR 1.5 times that. So we're going to take, on the female case, so we're going to take 1.5 times 6, and that comes out to be 9. So we're going to add 9 to Q3. Remember, Q3 is 56. So if I add 56, I add 9, that's going to be 65. Now, in this case, there's no outliers. But what I want to show you is, what if, well, actually, there is an outlier. 65 is an outlier, right? If it's in the data set. Well, there's no 65 in the data set. However, there is a 74. 74 is going to get a little bitty star as it's the outlier for our data set. Okay? So when I connected this whisker to 60, I connected it to the next highest value. Even though 74 is my max, I'm not going to draw my whisker to 74. You might have been wondering why I did that. I drew it to the next highest value because I needed to check the extremes. All right. If I do the same kind of thing on Q1, which was 50, if I take 50 and subtract 9, I would be back here at 41. Well, 46 was the lowest value in the data set, so I don't have any outliers.